help customers develop, test, and deploy custom solutions to the cloud. You can find me on Twitter at jasontaylordev or on my blog, jasontaylor.dev. Today, we're here to look at authorization with ASP.NET Core, basic approach, and a flexible approach. A little bit of background information before we get started. So authentication is the process of determining a user's identity, whereas authorization is the process which establishes which resources a user can access. Authentication is independent of authorization, but it's important to remember that authorization requires an authenticated user. So authorization determines access to resources. But what exactly is a resource? Well, it can be many things. Inside the application, it could be a page, a view, or a capability. Outside, it could be access to data, such as in a database, or access to a file in the file system. Authorization also includes defining and enforcing access control rules as policies, which are then used by the system to accept or reject access control requests. So in this talk, we'll be focused on authorization. I'll demonstrate how to apply and enforce access control with basic authorization capabilities built into ASP.NET Core. And I'll show you that in some cases, that approach is going to be difficult to maintain. It will take a long time to develop, and it will decrease the overall maintainability of your system. I will then demonstrate a flexible approach to authorization by extending ASP.NET Core's authorization capabilities and show you how you can overcome those limitations. Now, the sample app I'll be using is built using Blazor WebAssembly, hosted on ASP.NET Core. And at the end of the presentation, I'll share the code and slides for that application. Before we get started, we'll have a little bit of background information on authorization with ASP.NET Core and then with Blazor WebAssembly. Now, ASP.NET Core, of course, supports simple authorization capabilities, and that includes allowing an authenticated user and allowing an anonymous user. It also includes sophisticated authorization capabilities such as role-based, claims-based, and policy-based. So basic capabilities are very good. It's easy to create custom authorization policies, and what's more, it's also easy to customize the authorization middleware. So you can extend the built-in authorization capabilities to suit your needs. At its simplest form, authorization in ASP.NET Core requires applying an authorized attribute to a controller, action, or razor page. You can see in this example, I've applied the attribute to the account controller. So that means that any of the actions in this controller require an authenticated user. And of course, that's a problem because now nobody can log in. So we need to fix that. Here, I've moved the authorized attribute down to log out. So you only need to be an authenticated user to log out, but anyone can log in. As another example, I've applied the authorized attribute to the top of the account controller again, and then the allow anonymous attribute to the login. ASP.NET Core also supports role-based authorization. In this example, we've used that same authorized attribute to specify the role of administrators to access the actions within the administrator's controller. So that means an authenticated user just needs to be in the administrator's role. Next up, we've specified two roles, administrators and accounts. Now this actually means or, so you have to be an authenticated user and you need to be in either the administrator's role or the accounts role. In this case, I've used the authorized attribute 2 times. So first for the administrator's role, second for the accounts role. And this means that an authenticated user will now need to be a member of both roles. So you can see that using the authorized attribute, you can combine it in various ways to set your access control policy. It also supports policy-based authorization, again, through the authorized attribute. Here I've specified that to access the employee's controller, the authenticated user must satisfy the requirements of the employees only policy. Now it's quite easy to define policies. You can see here we're doing it when we add our startup services, so add authorization. I'm adding a new policy called employees only, with a single requirement. The requirement is that the authenticated user must have the employee number claim. The value of that claim is not important for this policy. Next up, we'll have a look at authorization in Blazor WebAssembly. So it supports the same basic authorization capabilities, because of course, it's an ASP.NET Core technology also. So it includes the same sophisticated authorization capabilities, such as role-based, claims-based, and policy-based, view-based, resource-based, the list goes on. It also includes helpful authorization components, such as authorized view, which will allow you to selectively display content on your page, and authorized route view, which will be able to restrict certain routes to certain users. It's important to remember that with Blazor WebAssembly, or really any front-end web technology, that the authorization is just there to improve the user experience. Those checks can easily be bypassed, and so we have to still enforce authorization on the back end. So in Blazor, we can apply the authorize attribute to a routable page. Here, I've restricted access to the home page to authenticated users. In this case, I've opened up the login page to allow anonymous. In Blazor, we can apply that authorize attribute at a global level. And so here, even though all other pages might be restricted, the login page remains accessible. With role-based authorization, we can use the authorize attribute and specify the recommended roles. Policy-based authorization, again, Blazor page, we're specifying the employees only policy. So users requirements of the employees only policy access this page. Also apply the authorized view to display content. So the home link is available to authenticated users. Counter will be available to users who are a member of either the administrator or the accounts role, and the users link will only be available to users who satisfy the employees only policy. In this case, I've specified that the login nav link is available to users who are not authenticated. So let's kick off with the first demo. This is a simple one. We're going to add a role to an existing application using basic authorization capabilities. Now, I have the sample app. This is that Blazor WebAssembly app hosted on ASP.NET Core. And it has some functionality built into it, such as seeding of users and roles and that sort of thing. So I'm going to start just by logging in. Okay, so you can see it's pretty simple, straight out of the box. But I've built a users page where I'm able to come in and edit the roles assigned to a user. And I also have a claims page so that we can view the claims associated with the user. You can see that we're passing the roles in as a claim, so we have access to that information on Blazor WebAssembly. What I would like to do is to create a new auditor role so that I can allow the auditor user access to certain things within this application. I'd like them to be able to use the counter, fetch data, and view a list of users. So let's see what code changes we'll need to make to do that. So I have a DB initializer. And in that initializer, I've specified some roles. So you can see I have administrators, accounts, and operations. I'll duplicate that line, and we'll go ahead and create a auditor's role. And if I scroll down here, we're using ASP.NET Core Identity to create these roles. So I'll duplicate this line too, and we'll create the auditor's role. Now that's going to get the role into the system, so I could then assign it to the auditor, but now we need to actually use that role to secure access. So I'll start with the backend and securing the controllers. The weather forecast controller is currently accessible to administrators and operations, so we'll add auditors. I also need to add access for the users controller and the roles controller. Now we'll go to the front end and we'll update the nav menu. I'll just get rid of that. There we go. So you can see here the counter needs to be updated. So this is the authorized view component. We're specifying the roles for access in the counter link. Fetch data, we'll update that. Users, we'll update that. That's actually only accessible to administrators. And claims, we'll update that too, even though the auditor doesn't really require that. All right, so now that that's done, I just need to restart that application. I can log in as an administrator and assign that role to the auditor. Then we'll log back in as an auditor and see if we have the correct level of access. Okay, here we go. Okay, so in users, we can click edit on auditor and assign the auditor role, hitting save, then we can log out and hopefully the auditor will have access to what they require. Logging in. If you're looking for the passwords for this application, of course they're hard-coded, so you can find them in the DB initializer. Might want to take that out before we go to production. Oh, I'm registering. I don't want to do that. And password. Password 123 exclamation mark. No. There we go. Okay. So fingers crossed, yes, we have access to the counter page, but we don't have access to, we have access to the counter nav menu that's visible, but we don't have access to the counter page because I forgot to open that up too. So if we go to the counter page here, I have to update this. You can see it's easy to make mistakes with this approach. We have to get it right. Claims, fetch data, users, so many changes for such a little requirement. Edit. And this is a sample application. This is not an organization, a large enterprise application. All right, let's see if we can get hot reload to do its magic. No, we cannot. That's okay. So one last time, we should be okay. Here we go. Logging in. So we're seeing really an example here of role-based access control. And we're seeing that it's difficult to maintain and it's time-consuming. We tend to make mistakes, and those mistakes are not so easy to detect. Okay, counter, yes. Fetch data, yes. Users, we've given them a little bit more access than what we want. We don't really want auditors to be able to edit users, but okay. We don't really have fine-grained control of these permissions as yet. And we've got claims, and we can see that they're in the auditor's role. So that's it. So in that demonstration, in order to add a single role, we had to make code changes. We had to test those changes. When we're ready to go to production, of course, we're going to have to push it through our build and deployment pipeline. The application's going to go offline just to add a new role. And of course, there's probably going to be some bugs there, so we'll have to go back and fix those. We didn't document any of this, so nobody knows who has access to what. It's just in code. They'll come to us as developers and say, hey, who has access to what? And we'll go, we don't know. Hang on, let me do a full solution code review and document this for you because the document is out of date. So that's the basic approach to authorization with ASP.NET Core using role-based access control. So what would a flexible approach to authorization look like? Well, first and foremost, I want it to be easy to add new roles and to configure access control. I want to be able to also reconfigure access control for existing roles, and I don't want to have to do a deployment for that. I want to remove roles without impacting existing access control checks. If I want to remove a role now, I have to update a whole bunch of code to do that. And I want to easily view access control list. I don't want the business to come to me and say who has access to what. I just want that information to be available to them and automatic, not something that I have to create and document each time, because I'm not very good at documentation. I wanted to support all of these above features as standard application features. Okay, it should be built into the application. So now let's run this demo again, this time with flexible authorization capabilities, and see how much easier it is. So this is the same application, but we've extended ASP.NET Core's authorization capabilities to make it more flexible. So I'll log in as the admin, as before. The admin is the one who's responsible for managing the roles. Now there's a few more pages here. You can see that I have the ability to manage roles. So I'll go ahead and create a role. I could also update a role name or delete a role, and it will not impact the code in any way whatsoever. Then I have this really nice access control page, where on the left-hand side, I have defined permissions, and across the top, I have the roles. And it's easy for me to assign certain permissions to certain roles. So I'll assign the auditors view roles, view users, configure access control. That's a bit more access than what I want them to have, but we'll add a new permission soon. And we'll give them counter and forecast as well. You can see that administrators automatically get all of the permissions. And actually, when I add a new permission to the system, they'll get that too. We don't have to do anything for that. Okay, those changes have already been saved. It just happens automatically as we click. So I'll log out. No, I won't log out. I almost forgot. I've got to assign that role to the auditor. So we'll jump over to here and hit edit and hit save. There we go. That's like a demo failure averted. So lucky. So now we can sign in as the auditor, localhost, and password 123. Excellent. So we've got counter, we've got fetch data, we have users. We don't actually have the ability to edit. That's been cleaned up a little bit. We've got our claims. We have this interesting permissions claim, 117. That number represents the permissions that the user has. We'll learn more about that later. We've got our roles and we've got our access control. They currently got the ability to change access control. We don't want that. We'll fix that up with a new permission. Okay. So you've seen the basic approach. You've seen the flexible approach. I think we already know the difference, but let's do a quick comparison. With the basic approach, we had to make code changes. There was no way to avoid that. We had to test those changes. We did that manually. If we deploy to production, we'll have to build and deploy it. The application's going to go offline. We'll probably need to make some bug fixes along the way for whatever we missed, and we'll need to document those changes, which of course we forgot to do. Now with the flexible approach, we weren't really required. We just needed an authorized user or an administrator to go in and create the role and to assign the necessary permissions to that role. That just gave us free time, right? And that means that we can focus on building new features or fixing bugs or in some other way delivering business value rather than looking after access control. So let's have another demo now. Let's see how we can use flexible access control or flexible authorization to add a new permission to support a new requirement. So we'd like to add a view access control permission so that auditors have the ability to view access control and other users potentially too, but not to configure it, not to change access control. We'll stop the application running. So to do this, I need to open up the permissions file, which I'm currently storing as an enumeration. Now, depending on how many permissions you have and the approach that you would like to take, this enumeration may not work so well with you, but we can discuss other options as well. So to add the new access control permission, I'll just go view access control equal to 128, which is the next number in the sequence, and we'll talk about how this works and what the flags attribute means pretty soon. But for now, I just want you to focus on we're adding this new permission, view access control. Now we need to go to the access control controller. There might be a better name for that. And here, at the top of the controller, we've specified that for a user to access the actions within this controller, they must have the configure access control permission. So you can see with this approach, it's still nice and declarative. It's a little bit better, in fact, because we don't have a magic string. We have a nice strongly typed string to define the permission. I don't want to apply that permission to the whole controller any longer. I want to apply view access control. Let me just copy that. View access control for get configuration. And I want to apply configure access control for update configuration. Okay, so the controller's done. We need to fix up the nav menu, which is on the front end. So I'll go to the shared components, to the nav menu. And here, scrolling down, where is it? There it is. So we've got a flexible authorized view. I had to build a new component to extend the out-of-the-box authorized view so that I could supply permissions. So for this particular one, I want it to allow users to access if they have view access control or configure access control. So I'm able to specify those permissions. In fact, I can combine things like the authorized attribute in different ways to specify my access control policy. So next up, I need to open up the page. That's the nav menu. So I'll go to admin, access control index. And this can be the same. So configure access control or view access control. There we go. And that's it for the code changes. Now we just need to run the application. We can log in as administrator, assign the new permission to the auditor's role, and then check it. No, we're not finished. I forgot one thing. Okay, so we haven't changed the access control page to restrict changing, assigning permissions. And so to do that, we'll take this little checkbox and we'll give it a different state if the user is authorized to configure. We'll use the flexible authorized view component. We'll specify the permissions. And we're going to say if the permissions.configure access control, if they're authorized, getting a lot of help there, but it's not the greatest help. And if they're not authorized, okay. So if they're authorized, we'll leave the checkbox alone. They can go and change those permissions. If they're not authorized, we'll just get rid of this change event and go ahead and set it to disabled. That should do it. Okay, so we'll run that and have a look at the difference that's made. Okay, I'll log in as an administrator. And we'll go to access control. We see view access control. We'll assign that to auditor and we'll revoke configure access control. We can go ahead and log out and log back in as an auditor. So there's code work to do when applying a new permission, but that's normal. We'll typically do that when we're creating a new feature or implementing a new access control policy. Here we go, access control, and it's locked down. We can see access control, but we can't change it. All right, so I want to give you now an overview of how this flexible authorization system works before we dive into the code and see the actual engine. We use this system to create the necessary roles and permissions. The roles are created on the front end using a component or a page that we've created, and the permissions are created in the back end and then are available to be assigned on the front end. So we assign those permissions to roles as required, and this can be done by any authorized user who has the capability to assign permissions. We then add those permissions as a claim to the authenticated user. Then we add permissions-based access control checks where required. We can use the authorize attribute, the authorized view component, and we can use the ASP.NET Core iAuthorize service to enforce those permissions. Now the actual engine behind this is ASP.NET Core policy authorization. What we do is create dynamic policies to represent the permissions that have been specified in access control. We also need to manage roles. We know that roles define a logical grouping of users, and that administrators can create the new roles as required. They can assign permissions to the roles, and we need to take note that from this point forward, role-based authorization in our code should be avoided. We're taking those names, those magic strings, the roles out of the application so that our code base is shielded from those organizational changes. Managing permissions. Permissions, of course, define granular access to resources. We're much better to describe exactly what a permission will give a user than we are if we just assign roles to various capabilities. Developers create permissions as necessary, and permissions are not assigned directly to a user, okay? So we assign permissions to roles, and then the user inherits the permissions of any roles that they're a member of. The authorization engine, as mentioned, is built entirely using policy-based authorization. We saw an example of an authorization policy. It was the employees-only policy, which required the user to have an employee number claim. Well, we're building dynamic policies to suit the permissions required. So we can use a custom authorize attribute or other ways to specify required permissions, and those required permissions are then translated into a policy name. So we're generating a policy name. It's that policy name that will be used by a custom policy provider to create the policy for us. Now the policy will be dynamically created using a custom policy provider, and we're going to see how all of that works. So now I'll walk through. We'll have a look at the flexible authorization engine and how I was able to extend the capabilities of ASP.NET Core to implement this and to make our life easier. Okay, we'll start with permissions.cs. We saw that briefly before. So permissions.cs is an enumeration. It's currently int-based, and that means that there's 32 possible permissions that we can define for this system. If we change it to long, we can have up to 64 possible permissions. If we're going to go over that for a complex application, we'll need to think about a different strategy for storing our permissions. Perhaps we'll put them in the database, and that will change how we add permissions to the user's claims, and it will also change how we produce the policies to enforce those permissions, but it will be the same engine. There will be some changes required. So we're using flags, and that allows us to combine these permissions in really interesting ways. I created a .NET Interactive notebook so that we can explore this together. So permissions in this example are using the flags enumeration, and we have permissions A through to E. Now you can see that those values are in powers of 2. We also have some special values, permissions none and permissions all, which is the complement of none. Now we can do really interesting things with these permissions. So you can see here I've defined some user permissions, permissions A or permissions C. And if we add the binary values of these permissions together, which is 1 and 100, we get 00101. So these flags represent the individual permissions of A and C. If we convert that to the integer value, or the decimal value, then we get 5. And that's the value that was being stored in the permissions claim. And that's how we know, using a single number, what permissions the user has. We also define required permissions the same way. In this way, we've got required permissions of A or B. So if we're authorizing a user against those required permissions, this user, the user needs to have either permission A or B. In this case, the user would be authorized because they have A. If we add these two permissions together, it's 1 and 10 binary, and that converts to decimal 11 or 3. So let's have a look at how we can use this. So first thing I can do is I can just right line the user permissions to the console, the enumeration, and it will give me the string value. So user permissions A, C. The required permissions, as you remember, will be A, B. And then I can also output the decimal value as an int, which is 5 and 3. I can check permissions, so we know what the required and the user permissions are, and they're authorized if they have that particular permission, so either A or B. Here, we're using the logical OR operator to add a permission. So they have A and C, we're adding B, so they now have A, B, and C. And here, we're using the exclusive OR operator to remove that permission, so back to A and C. Now these operators are quite nice for adding and removing permissions, but it's not something that you'll typically do with the flexible authorization. Generally speaking, the most that happens is we loop through the roles, we build up a collection of permissions for that user, and we assign it to the claim. So we're not tending to operate on permissions in this way, but it's good to know that you can. Now here is how we create those dynamic policy names that allows the custom policy provider to generate a policy for us. We can see the required permissions are A and B. We're going to prefix the policy name with the word permissions, and then we're going to append to that the decimal value of the permissions. So this particular policy will be called permissions 3, and based on that, ASP.NET Core will be able to build a new policy, extracting that 3 and then enforcing the required permissions. And we'll see how that works. This is the reverse of that code, where we take the policy name, permissions, I don't know what that one will be, A plus B and C, and we take out, I think it's 7, and then we take out the permissions value from the policy name. There we go. So we can see from that value of 7, the required permissions are A, B, and C, and the policy name was permission 7. Oh, sorry, that was just updating the required permissions and policy name. So I read that wrong. But here's how we can get the permissions value. So we're taking out the integer value, passing it, and then casting it into the permissions type. So if I run that again, permission 7, A, B, and C. So that's how the permissions CS works. Now let's have a look at some other parts. We've got to figure out the best place to move to next. How about the policy name helper? That's a simple one. We can check, is it a valid policy name? We can pass in the policy name, and if it starts with the prefix, which is permissions, then we're going to say, yes, that's a valid policy name. We can generate a policy name given a set of permissions, and that'll be the prefix and the permissions value. We can get the permissions from a policy name by using the prefix length and grabbing that int value, casting it back to permissions. So that's just a nice little helper function. Let's see what else we have. We've got the authorize attribute. Custom claim types are simple. The claim name will be permissions, and we've just got a strongly typed value for that. Let's see. That one's just a little helpful one that I use to get a list of available permissions, where I loop through the values of the enumeration and display the value. So let's get into the important parts. Here's the flexible authorization policy provider. So you can see it's based on the default authorization policy provider, and there can only be one policy provider for ASP.NET Core. So we base it on that, and we ensure that we retain calls to the base class to get the policy. This is where it all happens. You can see in itself, building the dynamic policy is quite simple. This is all of it. So first, we try to see if the policy has already been created, because this may not be the first time we've checked against these permissions. If it has not been created, if the policy comes back as null, and it is a valid policy name, it's one of our permissions policies, then we simply extract the permissions value from it. So we have the value of the enumeration there. Then we use the authorization policy builder to add a single requirement to that policy. And that requirement is permission authorization requirement, and we pass in the required permissions. We then build that policy and add it to the options by policy name and the actual policy itself. Now, of course, if the policy already existed, we skip all of that and just return the policy. So the policies are created using a kind of lazy fashion, and if it's already been created once, it will just be returned. We need to look at the permission authorization requirement now, which was the only requirement of a permissions policy. You can see that it's really just a container for data. It's based on the iAuthrization requirement, and it stores the required permissions. So there's another class that will actually help us to evaluate that, and it's the policy authorization handler. There's a little bit of code in here, but in the end, it's quite simple. First, we find the permissions claim, and that gives us all of the user's permissions. Then we assess that against the required permissions, and if they're authorized, we simply return context.succeed with the requirement and return task.completed. For anything else, we're just exiting. They won't be authorized. Let's see what else we have. Yes. Sometimes we're writing procedural code. And with ASP.NET Core, when we do that, when we want to authorize procedural code, we use the iAuthrization service. I've extended that with a authorize async method that allows us to pass in permissions. And of course, it's then just going to authorize against a dynamic policy. So all we do is say, hey, you want to authorize against permissions? Then you'll need this policy, which we just generate the name for on the fly. Let me see. We haven't looked at the authorize attribute. So the authorize attribute is based on the standard out-of-the-box one. All it does is add a new permissions property, which when you set the value, doesn't store the permissions value, it actually just sets the policy name. So you know what we're doing here is we're saying authorize permissions A, something like that, but we could also do authorize policy equals permissions 1. We're just making it easy for the user to interact with the flexible authorization system and to specify their permissions in a very clean and easy to understand way. So we can set the policy name when we set the permissions, and we can also get the permissions from that policy name as required. So we've extended ASP.NET Core's authorization, but it's still doing all the work. It's just policy-based authorization under the hood. Now, there's some other bits and pieces there. Let me see. Let me just make sure I haven't missed anything from this section. No, we looked at that. Okay. How about inside of authorization on the server, we have the application user claims principal factory. And that is the actual class that's responsible for adding the claim that contains the user's permissions. So you can see here, we get the roles, we loop through the roles, we build up the user permissions the user inherits all of the role permissions for which they're a member of, and we set the claim. So that's available. There's a little bit of work required on the front end as well, but the work is there just to take the roles from one format and convert them into another format. And that just makes it a little bit easier for us to work with. Otherwise, for Blazor WebAssembly, role-based authorization doesn't actually work. You need this little bit of code to get the roles claim into the right format. Oh, here's our flexible authorize view. That's the component that we built to allow us to specify permissions and therefore selectively show different components on a page. And again, it's driven by policy-based authorization under the hood. All right, I think that's it for the code walkthrough. Does anyone have any questions on what we've covered so far? Yes?
You know the matrix you showed with the policies and the roles?
Yes.
I'm not sure I could show that to my business and have them identify which permissions given access to which page, and that also be stored in the solution.
Yes. So you're saying that for the access control view, where it shows the permissions, you couldn't really show it to the business because it's not easy to associate a particular permission with a page, and there's really not that much information there. You could have a description or something per permission would be nice, and in actual fact, I haven't even put spaces in between the words. So there's definitely some work that we can do there, and one of the things is to apply some attributes to provide additional information to each permission in the flag. And of course, that'll depend on whether you're using the enum or whether you decide to take a different approach for the storage of your permissions. But yeah, you can certainly flesh that out further. Cool. All right, let's continue slide deck. Okay, so in summary, I've demonstrated authorization with ASP.NET Core. You saw that with the basic approach to authorization with ASP.NET Core and using role-based access control, doing something as simple as adding a new role took a lot of work. We had to write code, we had to build, we had to deploy, we had to do bug fixes, and we had to document those changes, which we didn't do. And we did fix bugs, right? I didn't plan to do that. That's just the nature of that style of authorization. It's tricky to get right. But then we saw the flexible approach to authorization, which was built by extending ASP.NET Core's authorization capabilities. And we could see then that adding a new role was trivial, and that adding a new permission took the expected amount of effort, nothing more than's required. Now, if your application is simple and it has a small user base, then the flexible authorization approach is probably overkill. If you only have an administrator's role and a user's role, you can definitely get by with basic approach to authorization. But for most production applications, especially those in large organizations, the flexible approach is essential. It's going to shield your code base from organizational changes. It'll shield your code base from department renames, from organizational restructures, from new departments that are forming. It'll only require an administrator or an authenticated user to maintain those changes, depending on their access level. And that's going to give us free time that we can use to fix bugs or to develop new features. We'll be providing greater business value as a result. Thank you for attending my presentation today. Thank you for listening. And if you're keen to learn more, you can access the code and slides on GitHub. So it's on github.com, jasontaylordev/flexible-ASP.NET Core-authorization. I hope you enjoy the rest of your conference. Thank you. Now I've got plenty of time if anyone has further questions. Yes?
Sometimes you have different roles or needs for example, different departments. So maybe how would you extend this kind of role model to
So different levels of roles.
Yeah.
Yeah, so I guess it depends on how many levels you need to support for your different levels of roles to support different levels of departments. One thing that you can do, if it's just 2 levels, then again, it can just be metadata on the existing roles that can specify kind of the higher level department. But if you did want to do nested roles and that needed to be represented in your application, then potentially what you could do, if using ASP.NET Core Identity, is to specify a parent role and basically build up a tree structure and assign permissions to different levels of those roles. Now, of course, you then have to decide, are there permissions at different levels, and do I navigate down that structure assigning those users the permissions as I go, or will it just be permissions at the leaf nodes? And so only at the bottom level will the permissions be assigned. So you have to figure out that for yourself. Obviously, it'll increase the complexity, but in the end, the user just gets that same set of permissions. Good. Any other questions? Yes?
Is it possible to combine this approach with regular policy-based authorization? So if I need, say, age checks or something, implement that by regular authorization policies?
So the question is it possible to combine this approach with regular policy-based authorization? And yes, I haven't overridden the policy-based authorization system, so you can still use policies, you can use roles. I wouldn't recommend roles though. You can use resource, you can use view-based access control, because all I did was really add permissions-based access control. Good question. Anyone else? Cool. Let's go get a coffee and enjoy the rest of the conference. Thanks, everyone. Cheers.